All right, so I put together this little video so that it would give you an opportunity to kind of think about binomials one more time, and hopefully by the end of this video you'll have a better understanding of the difference between a little b and a big B, and also how to use the tables to calculate the probabilities that go with various numbers of successes or various values of x inside of the binomial. So first let's consider this binomial distribution. Now I've picked one that's symmetrical, as you can see, and this means that the probability of a single success is actually 50%. The idea that it doesn't favor many successes or few successes, it's actually equal on both sides. Now what I've decided is that I'm going to use the one that has 9 trials, which means that there are 10 different outcomes in terms of either 0 successes in 9 trials, 1 success in 9 trials, and so on, all the way up to all successes in 9 trials. And over here, I've given you the values of x that we have available to us, 0 through 9. And I've also given you the little b's and the big B's. Now you'll notice that when x is equal to 0, little b and big B are going to be equal to each other, and that's because the big B is the cumulative. If we step up to where x is equal to 1, the little b is going to be 0.018, and the big B is actually going to be equal to this value plus this value. So you can kind of get an idea of how the big B's build over time, and ultimately at the end, the largest big B value is actually equal to 1. Now, these are not going to be the exact same numbers you would see in the tables, because in the tables they wouldn't give you this final line of 1 for 9, because that's true for every single distribution, so they just leave that off. Okay, so that's looking at the entire distribution. Now what happens if we break the distribution in pieces? Well, if we break it into pieces and we look at the bottom half, we have something that comes directly off the table. So this is actually big B3, and it's because x is equal to 0, 1, 2, 3. So this is big B3. This is exactly what you would get off of the table. Now, if we wanted to know what the value was for the top half, it's just going to be the opposite, which is 1 minus big B3. Now we can keep doing that with different values. This is big B5, so x is equal to 0, 1, 2, 3, 4, 5. Okay, and that's the bottom half. If we were interested in finding the top half, it would be 1 minus the bottom, big B5, and we would have 6, 7, 8, and 9. Now if we wanted to divide it directly in half, we would have big B4 on the bottom, 0, x equal to 0, 1, 2, 3, 4, and then 1 minus big B4 is going to be the values for x equal to 5, 6, 7, 8, and 9. So you can see how the complements work together. This is the value that you can get off of the table, and from that value off the table you can do 1 minus to get the top half. Okay, now let's see what else we can do to try to figure out what's going on. Okay, so let's say that we've gone ahead and said we want to know what is the probability for x greater than 3. Okay, so greater than 3 means that we are not including 3. We want 4, 5, 6, 7, 8, 9. So if you think about the entire distribution, which would be represented by this 1, what we want to minus off is big B3, because we don't want to include it. So the big B3 would have been right here, and this is actually the answer, which is big B3 minus, or 1 minus big B3. So this is 4, 5, 6, 7, 8, 9. Okay, now what if we want to do for x less than 8? Now again, for x less than 8 does not include not 8. So what we actually want is 0, 1, 2, 3, 4, 5, 6, 7. And that's just going to be big B7, right? Do not want 8? We use 7 right here. Okay, what if we said that we wanted it for x equal to 5 or more? Now in this case we want to keep the 5. We don't want to get rid of it. So what we want to get rid of is the 4 and below, which is going to be our big B4. So over here what we've minused off is the 0, 1, 2, 3, 4, and what we've kept is the 5, 6, 7, 8, 9. So this is the value under the curve that's going to be the probability for x equal to 5 or more. Now if we do less, for x equal to 6 or less, remember again we want to keep the 6, so we have to keep the big B6. So hopefully you can see the pattern, okay? If we're dealing with greater or more, we're going to have to use 1 minus a big B. If we're dealing with less or less, we're going to have to use a big B. And the biggest thing we have to keep track of is whether we want to keep this value or we want to get rid of it. For less than 8, we do not want 8 in there, so it's 7 to 0. For greater than 3, we do not want the 3 in there, so it's 4 to 9. And then if it's equal, we want to keep it. So in this case, we get rid of the 4, and in this case, we keep the 6. Now we can do other things where we're actually looking at just finding what the little b is. Now if we want just the little b, we have to start with the big B4 that goes with it, mostly just because it comes from the table. So this value you can read off of the table. What we want to get rid of is all of these guys because we want just this bar. So big B3 is just those guys. So if we do big B4 minus big B3, then we actually get this green arrow, this green bar is all that's left, and that's going to be equal to B4, exactly what we want. Okay, now another way we can do it is just say that our binomial has a value of x, for x equal to 4 or 5. So just because we're looking for little b's doesn't necessarily mean that we're looking for just one value. So down here we want 4 or 5. So we start with the big B5 so that we have something to start with. And then we minus off everything we don't want. We want to keep the 4, so we minus off the 3. So the big B3 gets minused off, and this is our answer, just these 2 bars right here. Now, the reality is there's lots of possibilities. I only gave you a couple, but you can do a bunch of different stuff. This is going to be big B1, right? And this is going to, because it's 0 and 1. This is 1, 2, I'm sorry, 0, 1, 2. So this is big B2, big B3, big B4, big B5. And then you can also look at, keep going from there. So there's lots and lots of possibilities, lots of things that you can do with binomials. The biggest thing to keep track of is whether you're thinking about more than x or less than x. If you want more than x, you're going to have the top half of the distribution, so it's going to be 1 minus the cumulative. If you want less than x, it's going to be just the cumulative. If you want one value of x, then you're going to need 2 big B's. The big B that gives you the top half of it and then minus off the bottom half of it. So hopefully that helped kind of clear out what binomial is all about. If you're still thinking that it's like, I can't think, just watch it again. That's the great thing about these videos. You can watch them over and over again. Thank you very much.